Here we're going to rationalize the denominator when our index is greater than 2. So you can see here that we have a cube root of 2. So we can't just multiply by another cube root of 2 because it isn't enough. If you have a cube root of 2 times another cube root of 2, if you remember, it takes 3 things to come out. This is the cube root of 4. There aren't enough 2's to come out. You would need 3 of them. So this is not going to be helpful. So what do we need? Well, we've got 1 2 under there. So what we really need are 2 more 2's under there. We need to have 2 and another 2. So we're really looking to multiply by the cube root of 4. So we're going to do that. I'm going to multiply by the cube root of 4 on the bottom and on the top, because remember, you're really just multiplying by 1. We're going to eliminate that terrible color. And now on the top, what we have is 6 times the cube root of 4. Again, 4 is 2 times 2. There's not enough 2's to come out. We would need 3 of them. All over the cube root of 8. And that is 2. So you have successfully rationalized the denominator there. The only thing that you can get rid of right now, if you wanted to do some canceling, is both of these are rational numbers. They're both outside of the radical, so we can cancel. 2 goes into 2 once, and 2 goes into 6 3 times. So our final answer would be 3 cube root of 4 all over 1. So essentially just this. Okay, so now we have one that's a 5th root, which is a little bit fancier. In order to eliminate this radical completely, we need to have perfect 5th roots. So I've made a little work area. So we're going to need to multiply by something that's going to make us have perfect 5th roots. So right now, that 4 is 2 times 2. It's 2 squared. Well, we need 5 to come out. So we're going to need 3 sets of 2's. We're going to need 2 cubed, which is 8. And we have x cubed. We have 3 x's. So we're going to need 2 more, which is x squared. And now we have a perfect x to the 5th. So we are going to multiply by the 5th root of 2 cubed, which is 8, and x squared. And if we look, we can see you'll have 5 x's in there, and x to the 4th is 2 squared, and x to the 8th is 2 cubed. So again, that's going to make 32, which is x to the 5th. So this is perfect. We're going to multiply by this on the top and the bottom. So 5th root of 8x squared, gross. And when we multiply this together, we are going to get 3x times the 5th root of 8x squared. And then on the bottom, everyone is going to come out. So a 2 will come out and an x will come out. And you can finally, in your last step, we have 2 things that are rational. They have no radical. We can cancel. 3 and 2, nothing in common. Don't cancel. But x over x is just 1, so they disappear. So finally, our final answer is going to be 3 times the 5th root of 8x squared all over 2. So the final, yikes, I seem to have